I said, no, I'm going to create a different engine. There's too much in our C++ engine. There are too many classes. There's too much going on. And we've got shaders and we've got it's too messy. If you want to port the engine to a different platform, you have to do way too many things. So I said, you know what, I'm going to go back to C, which was my original love of programming. Again, I spent quite a bit of time doing C++, Java, C# as well. And going back to C was like drinking fresh water again, like something like that. You just focus on what you want to build. And so I shifted more towards structured programming rather object-oriented. And then never look back. I'm so much more efficient with it. It's basically 100% of my time is spent writing the code that tells the computer what to do, not managing the hierarchy. The other problem with object-oriented is that quite often you start building these abstractions, right? So you start your project, say, okay, I think I'm going to need a controller model. Oh, the view will be like that. This will be the hierarchy. Then you start writing your code, and then you say, but now I want to do this, which is kind of an exception. So you start hacking your system to support a new feature that is cross hierarchy, right? And that happened to me, a lot. Like one of our most successful mobile games is called Planet Quest. It's a rhythm game. It's a lovely game. I love the game. And at some point that we had the idea of coming up with a level where you zoom the planet and you got like an infinite canvas of zoom, and then the planet inside the planet is the same as the previous one. It's a bit of a strange feature, but that's what we wanted for our game. And that went completely against the hierarchy that I created for Planet Quest. It was a massive pain to do it. I found a way. It's not pretty. It works well. It's stable. But it's one example of where, okay, you start with an initial concept or how your game is structured, and then you end up with a different, you want to do something different, you're fighting your hierarchy. While in C, if you program in a more structured way, you write what the computer should do. It's a list of operations that a computer should do. And using an approach that is called semantic compression, you start seeing the common patterns and you put them in common functions. And the code naturally kind of flows towards some kind of order that makes sense and is the right abstraction. If you want to know more about this, you can follow Casey Muratori. He's done a Handmade Hero, which is, I'm sure you're familiar with the series on YouTube, where he creates a game from scratch and he goes through similar ideas. So again, why C is the same reason why Casey Muratori is using it for Handmade Hero. And also, again, for me, it makes how you can focus on the game, not on the abstraction. So you want to create that sometimes you do it too soon and then you fight them for the rest of the project.
Yeah, Casey Muratori is mentioned, I think, once every 2 episodes at least at this.
Amazing. Yes, that's good.
Podcast.
It should be.
It's like a lot of people who end up dissatisfied with the, let's say, state of the programming. Let's say the common state of the programming nowadays. They someone drive towards like find Casey Muratori's Handmade Hero and start from there, building up their own mental models, how things can be done. And it's interesting. Like, I think I would agree with this. A lot of the games, even, you can see that they are now written in these concepts in mind, that there are objects, and this forces this structure and architecture of objects forces also gameplay to behave this way. Like you mentioned, you can't have like a wacky transitions even between like planets. If you created an architecture and you are made sure that this planet only controls this part and this planet controls this part, and now they have no way of interacting together because you just spent like hours making sure they won't interact. And this is like putting a lot of constraints on what you can do. And I feel you can see it in games now. If you have like, especially the strategic games, there are systems that are so isolated from one another that it's difficult to imagine they're flowing through. Like rendering is so, let's say, put separated from gameplay, that you don't have a lot of tricks from going through rendering to gameplay, because it's just so separated and so different in this build in this like separated way.